Hello, I'm going to be going over some trigonometric functions today. We're going to be talking about tangent, or it usually goes in this order: sine, cosine, and tangent. So let's make it a different color: sine, cosine, tangent. An easy way to remember this is SOH-CAH-TOA. Okay. To make it more visible, I'm going to change this to black. Better. Okay. SOH-CAH-TOA. Sine, or the S stands for sine. Opposite for the O over the hypotenuse. Okay. This is going to be, I'm going to space this out a bit more. So we have tangent. Oh, forgot about cosine. And tangent. So you're going to get, just keep it. Cosine is adjacent over hypotenuse, and you'll learn more about what this means in a little bit. And then tangent is opposite over adjacent. Okay, so you start with a circle. You have the x-axis and the y-axis. So what do we start with? Sine. If you take the sine of 45 degrees, the first thing that you do is you draw the 45-degree angle. Boom, 45. And you have the bottom. Now, what you do is you draw a perpendicular line to the x-axis. So that is a 90-degree angle. So we know 45 plus 90 equals 135, and then 180 minus 35, or 135 is 45. So say 45, 45, 90 triangle. Looks like this. Oh, nope. 45, it's, okay. 45, 45, 90. There you go. And so the ratio, each of these corresponds with a side. This is the opposite side of 90. This is the opposite side of this 45. This is the opposite side of this 45. This is special, along with the 30, 60, 90 triangle. This is 60. And the thing with these two triangles is they have special ratios of the sides. And so it is x, x, and x rad 2. Oh, nope. Yes. Yeah, it actually is. And then for this one, you have x, x rad 3, and then 2x. And so that is opposite the 90-degree angle, and yeah, you keep this. So using this, if this is a 45-degree angle, and this is a 45, 45, 90, we can assume that the radius of the circle is any number. Let's do 1. 2 is pretty common also, just because of the 30, 30, 30, 60, 90, because it makes it easy for this. But let's assume the radius is 1, so that makes, let's use a different color. Sure. That makes this 1, because that's the radius, this side of the triangle. And so, okay, so what you do, since x rad 2 equals 1, because that's a proportion. So now we're trying to find x. So x equals 1 over rad 2. And then you can't really leave a square root on the bottom, and so it becomes x rad 2 over 2, or x equals rad 2 over 2. So this is rad 2 over 2, and since these are the same, this is rad 2 over 2. So now we have all the sides. So we have the hypotenuse, we have the, it's all in terms of this angle. We have the adjacent side, and we have the opposite side, because that is opposite that. So now, to find sine, this is 45 degrees, just to make it clear, but that made a mess here. 45 degrees, so we find the opposite side, rad 2 over 2. Then we take the hypotenuse, so it's over 1. And that just equals rad 2 over 2. For the cosine, let's just erase all this. For the cosine, we take the adjacent side, rad 2 over 2, and we divide it by the adjacent side. I messed up, but it's still the same. Opposite side, nope, adjacent over hypotenuse. So adjacent side over the hypotenuse. So the identity element just means that that's, again, 2 over 2. Okay, now we're gonna erase it. I'll keep the x down there. And we are going to do tangent. Ooh. The tangent of 45 degrees. And so you do opposite side. So rad 2 over 2 over the adjacent side, rad 2 over 2. And then the identity property states that that is just equal to 1, because 2 over 2 equals 1. Any number over itself equals 1. So the tangent of 45 degrees equals 1. That is the basics. You can get into it more, like the tangent. Let me get rid of this. The tangent of 180 degrees. Let's make it 210. 210 degrees. That's important. So we can get rid of this. Okay. This I'll keep. This I need to get rid of. This is the x-axis. So the tangent of 210. 210, so the angle would be here. When you have a degree like this, you're trying to get it back to the first quadrant. You're trying to get it to an acute angle, which would have to be here, because it has to be less than 90 degrees. And so to do this, you need to think of it, you're trying to, basically, this angle is 180 degrees, okay? This is 30. You need to compare the extra to the x-axis, because I could very easily do this, but that's incorrect. Well, that's not the way that we're going to be doing it. So you need to, if we had an angle that went here, you'd compare it here, not here. You compare it to the x-axis. That's important. So this is 30 degrees right here. So the tangent of 210 degrees equals, we also have this. So this has to do with the quadrants. All students take classes. So basically, this tells us what is positive in which quadrant. All of them. Sine. all sine, tangent, and cosine. That shows us what is positive in each quadrant, and it shows us what is negative, because if a tangent is in this, then it's negative. So the tangent of 210, this is the first sector, this is the second, this is the third, so it's actually positive. And so the tangent of 210 is tangent of 30 degrees, that they are equal to each other. However, if you had the cosine of 210, it would not equal the cosine of 30 or 30 degrees. It would actually be the, so we know that it's negative, so it would be the negative cosine of 30 degrees. That, yes. So let's actually continue with this, the cosine. Okay, so you take this, 30 degrees. We did the 45, 45, 90. Now we get to do the, now we get to do the 30, 60, 90. And so we will get 30 degree angles about that. Let's use a different color though. Okay, 30, draw the perpendicular, 90, and 60. Okay, so make sure to draw this line. It's a triangle right here. So let's, anything for the radius. So we're going to make it 2, because that's the easiest thing. Because now you just know x equals 1. So now we know that this is 1 times, that is very messy, square root of 3. It's 1 times the square root of 3, which is just square root of 3. And then we get 1 here, because x equals 1. So the cosine of 30 degrees, or the negative cosine of 30 degrees, is, we just do this. Adjacent, hypotenuse, or adjacent and hypotenuse. So rad 3 over 2. That is the negative cosine of 30. However, you make it negative. So that is the answer for that. I believe so. Cosine, yep. Perfect, yeah. And you make it negative because there's a negative sign right here. So that is that part. And then that's really, once you know this, you really know a lot. If you have a negative degree, so if you have the tangent of negative 300, this negative, okay, if we just look at a circle, if you go negative 300, you're starting here, and so you're going negative 300, and you end up around here. That is the same as the tangent of 60. Just negative, that's not really trigonometry. That is kind of just circles or angles. Basically, this is equal to this. Well, like going this way, so negative 300 degrees is equal to 60 degrees. You basically, if you have a negative, you add 360 to it as many times as you need until it becomes an angle like this. That's the best way I can explain it currently. And so this is 60 degrees now. So now, if we really just, we can keep that, yeah. We have this, you know how to do this. It becomes a 30, 60, 90. So now it's flipped though. So you need to be careful. Look at the opposite sides. So if we make the radius 2, okay, which is really this, radius 2, but this is part of the radius. So 2. Then the opposite of the 30 degree angle is now 1, and this is rad 3. So now we could do all 3 of these right now. Let's just do the tangent. Tangent of 60 degrees is, yeah. Tangent, you take the opposite side, rad 3, rad 3 over the adjacent side. Oh, nope, that's messed up. Should be something over rad 3. So you take the opposite side. Yeah, okay. Opposite. So you take the rad 3 over the adjacent. Yes, I know what I messed up now. This is the adjacent. So it's rad 3 over 1, which is just rad 3. So tangent of 60 equals rad 3. That is the basics. The most important thing is this right here. That is extremely important, because then you know if you, like, tangent of 300, let's take that. This becomes, so you take 300, which is this is 90, this is 180, this is 270, so tangent of 300 would be it would be over here with the 30-degree angle right there. But we are not going this way. We're going to the x-axis and the closest possible way to it. So we take this. And so since this is a 30-degree angle, and we know that a whole quadrant is 90, we know that this is 60. So 300 actually equals the tangent of 60, which is convenient because we just did that. It turns out to be rad 3. Boom. So the tangent of 300 equals rad 3. However, I actually just skipped a step. Very crucial. The tangent is in the fourth quadrant, and the only thing positive is the cosine. So it would actually be the negative tangent of 60, so it becomes negative rad 3. Very important because of this. And another very important thing, just really helpful, SOH-CAH-TOA and this. Very important. Very, very important. So that really concludes our lesson for today. That was basic trigonometry. Mazel tov, you made it.